Hello, everybody. Today we're going to be talking about something called Vesper theory, which it's an acronym VSEPR. And what Vesper theory is it is the valence shell electron pair repulsion theory. In other words, it's a theory or a scientific explanation that in the valence shell, or the outermost energy level of an atom, the pairs of electrons repel each other. Because electrons, they're negatively charged, and negatively charged things repel each other. And so, because that happens, in covalent compounds, these electron pairs repel each other. This is what gives molecules their geometric structure or their shape. And that's really all the notes we're going to look at today. The rest of what we're going to be doing is an exploration. So we're going to be using the little Lewis structures you should have drawn over the past couple of days and this little simulation on molecule shapes that I'm going to share with you. So if we look at this kind of shows a very simple molecule that has three different atoms. We've got the purple one is the atom in the middle, and you can move these around. Then you got two other atoms attached or bonded with their electron pairs. They repel each other, so everything gets as far apart from each other as possible, which gives us a molecule geometry or a shape that's linear. If we were to add another atom to it, so we have three things bonded, it gives us a shape that is trigonal planar. You can see it makes a triangle, and it is flat. If we add a fourth thing to the middle, this gives us a shape that is called tetrahedral. It makes up a tetrahedron. If you don't know what a tetrahedron is, there's a pretty good little Wikipedia article about it that'll show you what a tetrahedron is, but it's a shape made of four equilateral triangles. Which you can kind of see this forms a triangle on each side. We're not going to do anything that involves more than four things attached to the central atom. They do exist, but we're not going to focus on them. So where things get interesting, however, is if we swap out one of these atoms attached to the central atom for a lone pair or an unbonded pair of electrons. For instance, the NH3 molecule, remember from drawing that, you got nitrogen in the middle, you got three hydrogens, and then you have an extra pair of electrons on the nitrogen in the middle. So let's see what that does. Well, this puts us back in something that's essentially the same type of shape we were dealing with previously, but the shape of the molecule itself is now a little bit different because we don't include the electrons in the shape. So it's kind of like the trigonal planar, but it's a little bit bent into a kind of low pyramid shape here. I don't know if you can really see that. But this shape is called trigonal pyramidal. The electrons are arranged in a tetrahedral arrangement, but this is called trigonal pyramidal. If we do another one of these, so we have two lone pairs of electrons on there. Now we have essentially what looks like a water molecule, where you have the oxygen in the middle with two hydrogens, and then you have two lone pairs of electrons. This shape is called bent. So a water molecule is bent. As we'll see in our next lesson tomorrow, that has serious implications for properties of water, for life on Earth, all that good stuff. If we were to swap out a third atom for a lone pair of electrons, well, now it's just linear because the only shape you can make with 2 points is a line. So what I want you to do with the simulation is kind of go through and see if you can create the molecules that we've drawn on those two Lewis structures worksheets and see if you can identify what shape they would be. For for instance, let's just look at one more. If we had the carbon dioxide molecule, it had a carbon that was double bonded to two oxygens. You would just draw it like that. And as you can see, these two things get as far apart from each other as possible. We could even look at the angles on here. It's 180 degrees. This shape is linear. There's all sorts of cool things you can do with this simulation. I just want you to kind of play around with it. Just if you have a resonance structure for a molecule, just create one of them. All the others are the same. They're just rotated in space, essentially. But just go through each of the molecules and take a look at it. You can also, down here at the bottom, flip over to real molecules. This shows water molecule, or carbon dioxide, or sulfur dioxide, or there's all sorts of things. There's NH3. So you can kind of mess around with those. But with the model, it lets you build your own things. And you can build some really crazy stuff. If you want to look at some really weird shapes, like my personal favorite, which is the seesaw shape. But this is stuff more for AP chemistry. But it kind of looks like a seesaw if you look from that perspective. So there's some cool things that you can make on this. So just spend some time playing with that. All right, good luck.